Bismillahirrahmanirrahim. Assalamu alaikum. I am Dr. Faizullah, and in this lecture we shall study the Taylor series for complex variables. This series was introduced by a British mathematician, Brock Taylor, in the year 1715 in a general disk of this form. Later on, a Scottish mathematician, Colin Maclaurin, considered its special case. He fixed its center Z0 equal to 0, and that is why the Taylor series centered at 0 is also called the Maclaurin series. So let us start from the statement of this series. If we are given a function f of z which is analytic in this disk, then this function f of z can be written in the power series representation, which is given by f of z is equal to summation n is from 0 to infinity an into z minus z0 power n. And if I expand this, I can get a0 plus a1 z minus z0 plus a2 z minus z0 whole square and plus up to so on, where an is equal to the nth derivative of the function f of z at the point z0 divided by n factorial, and is called the Taylor series. The Taylor series. Now if we put n is equal to this thing in this formula, we will get that f of z is equal to summation n is from 0 to infinity nth derivative of the function f of z at z0 divided by n factorial into z minus z0 power n. If I expand it, I can get that f of z is equal to, just put n is equal to 0 here, here and here, and we will get f of z0 plus, now put n is equal to 1 and you will get the first derivative of the function at the point z0 into z minus z0, and plus f double dash of z0 divided by 2 factorial and plus into z minus z0 plus up to so on. Now you can see that the center of this series is z0, and also from the statement its radius is r. So what does it mean? If I draw the diagram, you will see that the center of this disk is z0 and its radius is r. So if z is some point inside this disk, then this series is convergent to the function f of z. And now if I put z0 equal to 0, I will get the Maclaurin series. So from here I can get that f of z is equal to, just put z0 equal to 0, and we can get that this is equal to n is from 0 to infinity and nth derivative of f of 0 divided by n factorial into z power n. And if I expand it, I will get f of 0 plus f dash of 0 into z, and plus f double dash of 0 divided by 2 factorial into z square up to so on. So this is a Taylor series centered at 0, and this is also called a Maclaurin series. So now let us use this series to solve some problem. The first example, I would like to find the Taylor series for a function f of z is equal to e power z. So find the Taylor series of f of z is equal to e power z around z is equal to 0, or we can simply say that find the Maclaurin series of the function f of z is equal to e power z. So to solve this problem, here f of z is equal to e power z, and if we look at the formula, what do we need? So here we need f of 0, then f dash of 0, f double dash of 0, and so on. So let us differentiate this function. If I differentiate this function, I will get that the derivative of e power z is again e power z, and if I differentiate it again, I will get again e power z, and so on. So similarly, the nth differentiation of this function is again e power z, and now I need f of 0, f dash of 0, and so on. So let us put z is equal to 0 here. So if I put 0 here and here, e power 0 is 1, I will get this thing. Similarly, if I put z is equal to 0 here, I will get 1. If I put 0, I will get the same number. And similarly, we can get that the nth derivative at z is equal to 0 is 1. So now what do we need? We need just to put values in this formula. So f of z is e power z, I have to put that f of z is e power z. F of 0 is 1, I have to put 1, plus f dash of 0 is again 1 into z, similarly z square, and plus up to so on. Or I can write that this is equal to ns from 0 to infinity and z power n. So this is the divided by 2 factorial and so on. So here I will get n factorial. So this is the representation of the function e power z in the Taylor form. And now if we remember this formula, we can solve many problems. For example, if someone say to find the Taylor representation of a function f of z is equal to e power 3z. So one method is this one, to do the same process. And the other method, if I remember this thing, just replace z by 3z and you will get the answer. If I have to find the Taylor series of the function f of z is equal to e power 100z. So one method to do the whole process, and the other just replace z by 100z and you will get the answer. So let us solve another problem. In this example, we have to find the Taylor series of the function z cube e power 2z around z is equal to 0. So as we know that to solve this problem, just look at here, e power z is this thing. So it is very convenient to write that e power z is equal to 1 plus z square divided by 2 factorial and plus up to so on. So, or we can write that this is equal to summation n is from 0 to infinity z power n divided by n factorial. So just replace z by 2z and we can get that e power 2z is equal to 1 plus 2z plus 2z square divided by 2 factorial plus up to so on. Or we can write that this is equal to summation n is from 0 to infinity, replace z by 2z. So this is equal to 2 power n into z power n divided by n factorial. And now what we need, we have to multiply both sides of this thing with z cube to find the expression for z cube into e power 2z. So just multiply both sides with z power 3. So z cube e power 2z. Also multiply here. We will get z cube plus 2z power 4 plus 2 square into z power 5 and divided by 2 factorial plus up to so on. Or we can write that this is equal to summation n is from 0 to infinity. This is 2 power n. If we multiply z cube, the bases are same. So here we can write that this is z power n plus 3 and divided by n factorial, and this is the required answer. Now we have to solve another problem. In this problem, let us find the Taylor series for the function f of z is equal to 1 over 1 minus z around that point. Again, you can see that we need f of 0, f dash of 0, f double dash of 0 and so on. So let us find that f of z is equal to 1 over 1 minus z. And if I differentiate this, I can get that f dash of z is equal to 1 over 1 minus z square. If I differentiate it again, I will get that this is equal to 2 over 1 minus z cube. If I differentiate this function again, I will get 2 into 3 divided by 1 minus z power 4 and up to so on. So similarly, I can find the nth derivative of this function. So from here you can see this is 1 factorial, this is actually 2 factorial, and this can be written as 3 factorial. So from here, if we have f triple dash, then we have third 3 factorial. So this is n, here we have to write n factorial. Now if it is 2, then here is 2 plus 1. If it is 3, here is 3 plus 1. So similarly, I will write 1 minus z power n plus 1. And now I have to put z is equal to 0 here. If I put z is equal to 0, I will get 1. Similarly, if I put z is equal to 0 here, I will get 1. And if I put z is equal to 0 here and here, I will get 2 factorial. If I put again 0, I will get 3 factorial. And similarly, we can get that if n of 0 is equal to n factorial. And now what do we need? Just put these values in this formula and we will get the answer. So let us see the answer. So from here, what is f of z? F of z is 1 over 1 minus z. I have to write 1 over 1 minus z. This is equal to fn of 0. This is equal to summation. N is from 0 to infinity. And fn of 0, this is n factorial. And divided by n factorial. And z power n. So these two terms will be cancelled. So we can get from here that this is equal to, if I put 0 here, I will get 1. If I put 1, I will get z square and plus up to so on. So this is the required solution of this problem. Now if we remember this series, we can find some more series from this one. For example, let us solve another example. In this example, I have to find the Taylor series representation of the function 1 over 1 plus z, around z is equal to 0. So you can see that we already have a series for 1 over 1 minus z. So we have to represent this one in the form of that one. So we can simplify this thing to get that this is equal to 1 over 1 minus of minus z. And now you can see this is the same series like this one. Just replace z by minus z in this series and you will get the answer. So the answer in this case, just write here, we can write that this is 1. And if I put z as a minus z, I will get minus z. Now plus, this is square, so I will get z square minus z cube and plus up to so on. So this is the series for 1 over 1 plus z. Now let us solve another problem. In this problem, we have to change the center. So let us solve an example. The example is that we have to find the Taylor series representation of the same function 1 over 1 minus z, but around the point z is equal to 5. So what we have to do now, because here the center is 5 now, so we have to make this center as 5, and for this purpose we have to simplify this function. So we can write that this is equal to 1 minus, and I replace this, I have to write z minus 5. To make the center as 5, I need z minus 5. So I have to add 5 and subtract 5. And if I simplify it a little more, minus 5 plus 1 is minus 4, and this is minus of z minus 5. So now I have to take 4 as common from here, and I will get that f of z is equal to 1 over minus 4 into this is now 1 and this is plus z minus 5 divided by 4. And now you can see that this is the same form like this series. Just z, replace z by z minus 5 by 4. So if I say that let this is 1, So what I have to do, just replace z by z minus 5 by 4 in 1, and you will get and from here now we can get that f of z is equal to minus 1 over 4 n2. Now this is 1 minus, replace z by z minus 5 by 4. So here I get z minus 5 by 4, and now plus, here I get z minus 5 by 4 square, and then minus up to so on. So this is the required solution. So now this is a series whose center is 5. Now by using the concept discussed in this lecture, I have to give you some homework. So homework is, number 1, if f of z is equal to sine z, find its Taylor series centered at 0. Number 2, f of z is equal to cos it. Number 3, f of z is equal to tangent z. And number 4, f of z is equal to sine hyperbolic z. Number 5, f of z is equal to cos hyperbolic z. And let us write the last one, f of z is equal to tangent hyperbolic z. So till the next lecture, take care. Allah Hafiz. Assalamu alaikum.